Hi, Christian. Am I audible and visible to you? Hi, Christian.
Hello,
How are you doing today?
good.
Good. All right. Where are you from, Christian?
Philippines.
Philippines. All right. Nice to know that. This year is Alok Jha. I'm from India. Yeah.
Okay.
And I've been teaching mathematics from last 15, 20 years. So, I have quite a lot of experience in teaching grade 9, 10, and year 11, year 12, right? So you didn't specify a topic, so I chose trigonometry to teach it today for a demo. All right.
Okay.
All right. So are you aware of a little bit of this chapter or this?
Not yet, sir.
Not yet. All right. All right. I'll do my best to sort of explain things to you so that you understand the concept pretty well, right? All right, all right, all right, all right. Let us see a situation, Christian. Take a look at this. It's you watching a tower over here, right? You watching a tower.
Yes.
All right. Do you see, do you notice your height here?
Yes, 4.5 feet.
Absolutely. All right. Do you notice the height of the tower? Is it known?
Huh?
Height of the tower, is it known here?
Is it known?
Not
It
yet. No.
no, no, right? Is the distance of the tower from you known?
Yes, 50 feet.
Yes. All right. All right. So do we have a geometrical figure here? Do you notice that? I mean, do we have a couple of polygons in this figure?
We have a triangle and a rectangle.
Very good. Wonderful. Wonderful. So, we can do this. I mean, we can simplify this figure a little like this. Say it. Say this is you. This is the ground over here. And this is the tower. Right. So you are watching the tower. This is the line of the side. This is an imaginary line, all right?
Okay.
Side, all right. You got to draw a horizontal over here to have a sort of triangle, of course, you know that, right?
Yes.
Yeah. Now you are able to see, uh, you know, a triangle and a rectangle. Wonderful, wonderful. What do we need to figure out? If we specify these corner points as A, B, C, D, and E, let's say, Christian, what do we actually need to find out? What does Christian want to know?
He wants to find the A and E and D.
Yeah, AD, right? That is the sum of
Yeah.
AE and ED, right? He wants to figure out AD, which is actually equal to AE and plus ED. Fantastic. And what all is given? What all is given, Christian?
CD and
Yeah, this is
CD and CD.
very good. This is 50 feet. So this must be 50 as well. This length BC is 4.5. So this is going to be 4.5. And this angle is given. Do you notice that? Do you notice
Yes.
that this angle is given? All right, fantastic. So this is 45 degrees. Now, the question over here is how to figure out AE. We know this ED is 4.5.
Yes.
If we can figure out AE, the length of AE somehow, then we are done. We will have the value for AD, right?
Yeah.
The question is how to find out AE. Do you have any idea of how to manipulate the data here and get the value of AE?
Mm,
No, right?
find the length of that one with the, I think, the angle and the 50.
Yes, we will use the angle and the length 50, length BE, that is, to figure out AE. And this is what trigonometry does. Are you getting me? This is what trigonometry does. We would, discuss more of these as we progress in our class today, right? This was just an introduction, what trigonometry does to you, right? You have to have triangles and specifically right-angled triangles in order to figure out things, right? Understood that? Did you notice that we have a right-angled triangle here?
Yeah.
Yes, absolutely. This is a right-angled triangle, Christian, right? Fantastic. So we'll be dealing in right-angled triangles throughout this chapter, okay?
Okay.
All right. So let me give you a briefing on what trigonometry does, what trigonometry is. So like trigonometry is made up of two words. Trigonon, meaning triangle. You saw that in the previous figure we had triangle, right? Triangle is a must in trigonometry. And metron refers to measure, right? Trigonon, metron. That means to measure triangles, to measure the parts of triangles. You saw that we had to find out AE, right, in the previous figure, the figure that was there. So we find out parts of triangles. There are 6 parts in total, 3 sides and 3 angles. You know it, right? You know it, don't you, Christian?
Yes.
Yes, you do. So that's what trigonometry does, to find out parts of triangles using the given parts. Some of the parts will be given, of course, right? All right. Now, like we just talked about, we have to use right-angled triangles throughout. So let's have a basic idea of what right-angled triangles are and what are its parts. Look, how would you speak of a right-angled triangle to a friend of yours, Christian? If someone asks you, yeah, go on.
A right angle would have an angle that is 90 degrees and it would have a hypotenuse.
Yes, absolutely. The definition of the right angle triangle would be just that it has one angle measuring 90 degrees, one angle measuring right angle, right? One angle is a right angle. Can a triangle have two right angles, Christian?
No.
No, because why can two angles not be 90 degrees in a
Because it
triangle?
would make a rectangle.
Then the sum of the interior angles will be 180, right? That is two angles. That is two angles will make up 180 degrees. So where will the third angle go? Right, that's the question. Which is why two angles cannot be right angle or obtuse in a triangle, right? At the max, only one angle can be right angle. So a right angle will have one angle, right angle. Fine. Now, what is hypotenuse? What do you refer? What do you define hypotenuse like?
It's the longest side of a right angle triangle.
Absolutely, fantastic work. It is the longest side and it is opposite to the right angle. Do you notice that?
Yeah.
It is the side exactly opposite to the right angle. Fantastic, boy. So you understood hypotenuse. You already understand hypotenuse.
Yeah.
Now, do you also understand, Christian, that the sum of these two angles will be 90?
No.
No, you don't, right? Okay. Let's once again state this. Sum of all angles of a triangle, sum of all interior angles of a triangle is
180.
absolutely. So angle A plus angle B plus angle C is 180, right?
Yes.
180 degrees. Now we know the value of angle P, measure of angle P, right? What is angle P?
Angle B.
Yeah.
B.
You can see it here.
Oh,
Angle B.
okay. A plus C.
Look,
Wait,
angle B is 90. It's stated over here, right? It is visible over here. It's 90. So angle B is 90 degrees, all right? Plus C is equal to 180 degrees. Am I correct with that, Christian? Do you agree?
yeah.
Absolutely.
Yeah.
So what is A plus C going to be? Come on, help me.
90.
Absolutely. There you go. You see that? A plus C, if one of the angles in a triangle is 90, then the sum of the other two angles will also be 90, right? Pretty interesting to, pretty important to note this. Fantastic, boy. You are super already. All right. Now, the first thing that we focus on in this chapter is Pythagorean theorem, all right?
Yeah.
Do you have any idea of what this theorem states?
Uh,
Come on, try it out, try it out.
Pythagoras theorem is used to find the hypotenuse.
Yeah, I mean, not only hypotenuse, but you can use it to find out any of the three sides, given the other two sides. If the other two
Yeah.
sides are given, then you can find out any of the sides using the Pythagorean theorem. It states, listen carefully, Christian, it states that the longest side, that is the hypotenuse, right? The square on the hypotenuse would be equal to the sum of squares of the other two sides, okay? So if we call this P, and if we call this, let's say, B, then H square would be equal to P square plus B square. Any confusions in understanding this? Tell me.
No, I understand it. I already learned this one.
Very good. Wonderful, wonderful, wonderful. So Pythagorean theorem is the first thing that you need to understand over here.
Okay.
Just a second. I will take you to this Pythagorean theorem. Let's apply this to a couple of questions. Shall we do a couple of questions, Christian? What do you say?
Yeah, okay.
All right, all right. You help me, okay? Your help is a must in solving these questions. See, read the first one.
Find the length of the diagonal of a square with a side of 10 centimeters.
Wonderful. So what do we do over here?
Using the picture, right?
Yeah, let's draw a figure. Let's have a square drawn. All right. Let's call this A, B, C, D. Let's call the vertices A, B, C, and D over here. Fantastic. All right. We need to find, do you think both, how many diagonals does it have? First tell me.
2.
Absolutely. Absolutely. Are the two diagonals equal? What do you reckon?
Yeah, they are equal.
Absolutely. So if we find one of them, that suffices, right?
Yeah.
Absolutely. Cool. So let's figure out AC. The side of the square is given to be 10, right?
So you have to find the area, then divide it by 2.
It's not area. We have to find out the diagonal, right? Like you said. So AC is to be found out. We just learned the Pythagorean theorem.
Oh, yeah.
Yeah, come on. Come on, Christian.
It's 10 squared plus 10 squared.
Yep, absolutely. And that is because each angle, each interior angle in a square is a right angle, right?
Yeah.
So if this is a right angle, then triangle ABC is right angled triangle, right? Triangle
Yes.
ABC in triangle ABC, we have angle B equal to 90 degrees. So, like you said, AC squared would be equal to AB squared plus BC squared. Any doubts in
Yeah.
this? This is the very
No.
theorem, Pythagoras theorem. All right. Let's plug in values. AC tan square plus tan square. There is a square over AC as well. So AC is going to be what? Come on.
200.
200, absolutely. AC squared is going to be 200. What is AC going to be?
Also has to be square root.
Yep, it has to be a square root. AC square root of 200. You are allowed to use calculators, right?
Oh yeah. Wait, I need to get a calculator.
Yes, you can.
Wait, be right back, sir.
You can get it, anak ko. You have it there?
Get it done.
Wait.
Square root of 200.
14.14213562.
Yeah, I mean, two decimal places will be
So 14.
14. Okay, fantastic. That's that. 14.14 is the length of the diagonal. Okay, let's give a try to the second one. What do you reckon we are gonna do over here, right, Christian? Read the question once.
PQR and PRS are right angle triangles. Work out the length of PS.
Absolutely. So PS falls in which triangle? Which right angle triangle?
Top one.
Yeah, top one, that is PRS, right?
Yeah.
But if you notice, this triangle has a couple of things missing. The hypotenuse is missing, and this side is also missing, right?
Yeah.
Only this side is given. How can we use Pythagorean theorem in this first? We cannot, right?
Yeah.
So
also find the one below.
Yeah, it'll be wiser to use the one below first, right? So what do we do in this triangle? Come on, help me.
4 squared plus 11 squared. And then we square it.
In triangle PQR, I'm just writing it for your reference, okay? So that you understand it better. It's up to you how you want to express it on paper, okay? Right, so here the hypotenuse is PR. You said it here, right? You understand that this is going to be hypotenuse, right?
Yeah.
All right. So PR is equal to RQ squared plus PQ squared. Any doubts in this? No, you said it yourself, I believe. So PR squared is equal to RQ. RQ, that's 4. Come on, help me. Next step.
137.
137.
7.
Yeah, it's going to be 137. Pretty good. Do we need to find out the square root of this? What do you reckon?
Yeah, it's 11.
This is tricky. This is interesting, I would say. Why is there why is there no need of finding out the square root over here? Can you guess?
Because you already 4 times 8 plus 112. That's already the end. You don't need to find it.
I don't get it.
You don't get it. All right. I'm here to help. Don't you worry. Look, we will again be using Pythagorean theorem in this, right?
Yeah.
And so
Oh,
we'll be having PR square in that Pythagorean theorem.
oh, okay.
So there is no need at all to find out the square root right here. We'll find out square root once we are towards the end. I mean the final step, that is, right?
Yeah.
The idea. So let's shift
Yeah.
our attention to this triangle. In triangle, PRS. Yes, absolutely. Ma'am is ma'am is also very good at this. PRS. What is it going to be? State the Pythagorean theorem in terms of the sides that are there.
5.4 squared
No, I
plus 1.
want you to state the names of the side in the expression.
Oh, so S and R.
PS is the hypotenuse, right?
Yeah.
PS squared is equal to, come on, help me.
RS
RS squared.
plus RP.
Yeah, PR or RP, it's one and the same thing.
Yeah.
Now, we are literally done with this. I mean, RS is 5.4 squared plus PR squared was already found
137.
out over it. Yeah, 137. There is no need to put a square over it. Do you understand that?
Yeah.
Yeah, that was the purpose of leaving it as it was. Okay, PS squared. Now find out the square of 5.4. Use calculator for that.
5.4. 29.16.
29.16. Add it to 137.
166.16.
166.16. Pretty good. Now you figure out the square root of this.
2 decimal
166.1.
places.
Yeah, in decimal places, couple of them will do. Will suffice.
12.89.
4.89. 12.
12.9.
12.89. That's absolutely correct. Wonderful work. Pretty good. Christian, you are wonderful. You are going to be fun to be with. All right. You know what, Christian? Have you seen XY plane? Have you dealt with this?
Not
No.
yet. I haven't learned it yet.
You haven't learned it yet, all right? You would be using a little bit of this in trigonometry as well, while dealing with Pythagorean theorem, all right? I'll tell you a little bit of it. Look, this is a surface. This is a plane. Plane. Do you understand the meaning of plane? So
Yeah.
plane surface. Yeah. Now, this plane surface has been divided into 4 parts. Do you notice?
Yeah.
By means of 2 numbered lines, mutually perpendicular numbered lines, X and Y. The 4 parts are this one known as quadrant 1, this one known as quadrant 2, this one known as quadrant 3, and this one known as quadrant 4. You understand that? Just a little bit of understanding here. I mean, not much is required for the trigonometry from this particular topic. All right. Now notice, if you have a point over here, let's say this point over here, A. Do you see? Can you figure out the location of this A with reference to the 2 axes that are there?
Which one?
There is a point A in green. Do you notice that dot?
Yeah.
What is its distance from y-axis? First tell me. Distance of the point from y-axis?
4.
That is the distance of the point from x-axis actually. This length is 2. Notice here.
Oh.
You understand that? This is parallel to this. So the distance would be same, right? That is 2. Okay. What about this height? Let me draw in blue. What about this?
4.
Absolutely. So you know what? We say that this A has coordinates 2, 4. Are you getting the idea? 2, 4.
Yeah.
These are coordinates. These are the values that help us refer to the location of a point. Location of a point in this plane. All right. Getting me, Christian?
Yeah.
Okay. So tell me the coordinates of this point over here. What do you reckon?
What? 2.
Is it 2 or negative 2?
Oh, -2, -2.
Negative
And
2
then
and comma
1.
1. Wonderful. Real cool stuff. All right. Now we wish to, let me erase this part. We wish to find out the distance between these 2 points. That means the length of this line segment. You know, Pythagorean theorem helps us in this. Okay, big
How?
time. How? Very interesting. A very good question, I would say. Look at this. I will tell you. You know what? We have a rule. We have a formula. AB. This is the distance between A and B. Okay, AB. What is it? This formula. It is the Pythagorean theorem only. I will tell you how it is derived in a short while. First, understand what is this formula. How does it work? Look. It is the difference of x coordinates squared plus difference of y coordinates squared. Are you getting the idea? Any bit, Christian?
Yeah.
You are right. So how do we proceed? How do we find out these differences? What do you notice? What are the x coordinates of the 2 points?
-2,
And 2,
comma
right?
1.
Look,
Yeah.
look. The first one over here is called x coordinate, the first one, okay? And the second one over here is known as y coordinate. So xa minus xb means -2, or you can start from here. 2 minus -2. Are you getting me?
Oh, okay.
Okay. Okay. And what about the second part? Come on, help me. Second part?
1 minus 2.
1 minus
Okay,
4.
1 minus 4. 1 minus 4. 1 minus 4.
Absolutely. 1 minus 4. Wonderful. So what would be the next step? Can you help me? 2 minus 2 would be?
2 minus 4.
Or 4 squared. And 1 minus 4?
-3.
-3. Wonderful. So this is 16 and plus 9. What is it going to be? 25.
25.
And final answer would be 5. What is it giving us? It is giving us the length of this line segment. What is it giving us? The length of this line segment. It is 5 units. It may be centimeter, meter, whatever you would like to use right now. It depends on questions. But you know, you can find out distance between any 2 points using Pythagorean theorem, right? If the coordinates are given. All right. Got the idea,
Okay.
boy?
Yeah.
Wonderful. So we discussed Pythagorean theorem today. If we continue, this is a long chapter. This has quite a lot of substance in it. If we continue, we would go into trigonometric ratios. Have you heard of sine of theta, cosine of theta yet?
Not yet.
Yeah, right. You would learn in time. You would definitely do. Okay. So we'll conclude.
Sorry, teacher, if I may, because I need to jump into another meeting, but I just
Yes,
want
yes,
to ask you a couple of questions.
yes, ma'am.
Teacher, they do, British curriculum. I just want to make sure that,